So guys, we are going to discuss a problem, coin combination 2, and we are going to discuss it with the method of dynamic programming tabulation. So the question is pretty straightforward. Our desired sum is 9, and as you can see, we can use the coins, and we can use the coins multiple times which are given to us. So let's try to solve this problem. So first of all, we are taking the input, and then also now if we are solving it with the dynamic programming tabulation approach, then we need to define that how will what does the state represent, right? So I am defining dp ind and x, basically the sum over here, and then what does it represent? Number of ways to make sum using the coins till ind, and I can use the coins multiple times. That's what our state represents, right? So what would be our base case here? So our base case would be pretty simple over here, that since I can make the sum 0 using any at any index, so I will just mark it as 1 over here, right? This will be our base case, and now what I want to do is I want to find the transition function, right? So what I will do is, let's say I want to make the sum, right? And I am at ind and sum. So let's say I would be using the array of ind coin at last, right? So what would be our answer? It would be dp of ind comma sum minus array of ind, right? Because also, and plus dp of when I am not taking the value ind minus 1 comma sum, right? So first of all, why I am not doing minus 1 over here? Because I can repeat the coins, right? I can use if I am given 2, I can use this 2 multiple times, right? So that's why I am not decreasing the index over here. If I have like let's say at the end 3 is coming, so then I have 6, then for that 6 I can use 2, it would be 4, then I can again use 2. I am again at that index 2, right? So that's why I am not decreasing ind over here. And why I am decreasing ind over here? Because I am saying that I will not be using ind at the last, so my full responsibility to make that sum is till the ind minus 1 at coin, right? So this is the logic which we are using for tabulation, and we are filling the values, and as you can see that this loop will make sure that the earlier values are already pre-computed, and then just we are going to just print the answer. Our answer would lie at n minus 1 comma x, right? Also discussing the time complexity and space complexity. The time complexity, as we can see, would be n into x, and the space complexity would be for this dp array and n into x, but there would be no recursion stack space complexity, so that is saved. Also one more thing, that I have used the matrix of n into x over here. So n into x, and n was about around 100 and x was around 1e6, so it is near about 1e8. This is just on the boundary case, right? So let's say you are using x into n as the matrix, so most likely this will give you TLE, because there is no cache locality in these type of uh, matrix. So basically what happens is that if I am traveling over the bigger inside, then I of 0, I comma 1, I comma 2, they are placed much closer to each other than right. So it is a concept of cache locality. It is much need to do with the internals of the C++, right? So yeah, if you want to study it, you can study it more. Also don't like it's just a learning thing. I also, like, as you can see that many times, so I was seeing into it, because earlier I was also using the x into n matrix, so you can use the n into x to get the solution accepted. So now we will submit the problem. So yeah guys, our solution is accepted.